Today on Scientific Tuesdays.
Action. Suspense. Evil alien symbiote?
Today we're going to look at 4 different demonstrations involving ferrofluid in powerful neodymium magnets. Ferrofluid is a liquid that reacts to a magnetic field. It's usually made up of a mixture of oil and tiny iron particles. Most people don't realize that we actually use ferrofluids every day. You'll find them in speakers, motors, even hard drives. But the real fun comes when you get a bottle of the stuff. For the first demonstration, let's try dripping some ferrofluid onto a magnetized bolt. Then we'll observe the results. Let's go.
Okay, so why do we call it a ferrofluid? Well, it's because it's a ferrous metal. Ferrous meaning iron. If you take a look on the periodic table, the symbol for iron is Fe. Thus comes the word ferrous for the symbol Fe. I've placed the neodymium magnet on the base of the screw. The magnetic force of this magnet is being transferred and carried through the steel in the bolt so that it acts like an extension of the rare earth magnet. Now obviously, the closer the fluid gets to the magnet, the stronger the force becomes. When the ferrofluid is poured onto this large bolt, we see it travel down the treads. Ferrofluid will naturally align itself to the magnetic fields of whatever object it comes in contact with. When you look at the periodic table, you can see that the materials that are in a column have similar properties. For example, take a look at 29, 47, and 79. These are copper, silver, and gold. To keep it simple, they are all soft metals and sit in the same column. But I definitely don't want to blind you with science. Let's finish up this experiment and I'll give you some more of the details a little bit later.
Now let's see how a neodymium magnet affects ferrofluid when it's suspended in water.
I'm going to start by pouring the ferrofluid into the water. You'll notice that as it hits the water, it beads up just like regular oil would if poured in water. But when I place the neodymium magnet to the side of the jar, it's going to instantly attract all the ferrofluid within range. Once we add the ferrofluid to the water, it's free to travel all over the jar, which gives us some really cool effects when we pull the magnet to it. For some reason, this makes me think of Spider-Man. Not sure why. Now, I was mentioning the periodic table of the elements before. The bottom 2 rows of the periodic table consist of rare earth metals. We actually find that neodymium is labeled number 60 and falls into those bottom 2 rows. This is why neodymium magnets are sometimes referred to as rare earth magnets. They get that name because they're made up of rare earth materials, as we've just seen here. Right now, they're the strongest permanent magnets in the world.
Now some of you out there are probably wondering what will happen if I drop the magnet into the water and ferrofluid concoction that I've got here. Well, let's find out together, shall we?
Now when we drop the magnet into the jar, all of the ferrofluid on the bottom quickly surrounds the magnet itself, forming a big ball of oily goodness. Even though this magnet is rectangle shaped, a magnetic force extends out in all directions. Think of it sort of like a light bulb emitting light in all directions. Because the magnetic force decreases with distance from the source, a circular ball is formed like we see here. Don't eat this.
Let's try it again, but this time I'm going to drop it into plain ferrofluid without any water. I'll pour it onto this plate and we'll go to town.
Now the first thing I'm going to do is pour out the ferrofluid onto the plate and make sure it's distributed evenly. When I drop the magnet onto the plate, it instantly forms a ball again, as you saw before. But you're probably wondering why spikes are forming. Well, think about it like this. Ferrofluid is basically thousands of tiny iron particles floating around in oil. Those particles line up with points where the magnetic field is strong and attempt to fully align with the field itself. When that happens, we see spikes because the surface tension from the oil puts a limit on how far they can go. Now you probably noticed that at the center of the ball, there are no spikes. This is a combination of both surface tension and the magnetic lines coming from each pole within the magnet. There's more force on each end of the magnet, so in the center, the magnetic field does not push out as far, forming an almost flat area.
And just as a little bonus for sticking around so long, I'm going to actually drink some Ferro fluid and see what happens.
Idiot.
Remember, if you drink this stuff, it's probably going to cause encopresis, which regardless of how cool that sounds, it's not a superpower. It might also kill you. Anyways, see you next time.